So last class we talked about our angle relationships, right? Alternate interior, alternate exterior, corresponding, all that stuff. Today we're going to use them in a few proofs. There will be one proof on your quiz. So good to know. Okay. Couple things to review. If lines are parallel, our corresponding angles are congruent. Remember, your corresponding angles make that F shape. So that's your little trick for identifying those. If lines are parallel, alternate interior angles are also congruent. Alternate interior angles are going to make your Z shape or like a zigzag. Yeah, this is incredibly sloppy. Here's what I'm going to do instead. Congruent symbol instead. You guys can write it out or use the symbol, I don't care. If lines are parallel, alternate exterior angles, also congruent. That's going to be your opposite V shape. Right? One V is going in one direction, one V is going in the other direction. If lines are parallel, what about same side interior angles? What's different with those? They're supplementary. So, yes, that was loud. Yes, same side interior angles will be supplementary. And same side interior angles, it's like your boxy C shape or like a staple. Okay. And if you are trying to prove that lines are parallel, last class we did that big chart where we had our angle relationship, what it looked like, and then the theorems that went with it. The last row in your chart was converse theorems. They were all flipped around. That's what we use if we're trying to prove lines are parallel. So use the converse theorems if you're trying to prove lines are parallel. So that just takes those statements up above and reverses them. If corresponding angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. So if the lines are parallel, you'll know these things about your angles, and vice versa. If you know that you have one of these angle relationships, then you know your lines will be parallel. And then we just have to fill out a few proofs about them. And your homework tonight's actually super short. It's like one page. I don't even think there's a back to it. Yes. Yeah, sure, Danny. Or maybe there is a back to it. But the whole front is basically like review of what we did before to make sure you guys understand it. What? Oh yeah, and it's like it's what? Oh, it's 7 problems. That's yeah. All right, so we are going to complete a couple proofs here. So for our proofs, we are given that angle 1 is congruent to angle 2 and that line L is parallel to line M. We want to prove angle 1 is congruent to angle 3. So we are given, and anytime you are given information, if it's not marked in your picture, please make sure you mark it. So we know that angle 1 is congruent to angle 2. And we know that line L is parallel to M. So normally that's your little arrows. I'll do those in a different color so we can kind of see it a little better. So those are parallel. We want to prove that angle 1 is congruent to 3. This is a very common type of proof that you see with these. This is probably very similar to what you will see on your quiz. What ends up happening is I will probably give you some parallel lines and an angle relationship. Now, what's the point of me giving you parallel lines? Well, parallel lines, if you're ever given them in a proof, they're good for only one thing. They only serve one purpose, and that is to give you congruent or supplementary angle relationships. So if you see some parallel lines, this is basically saying, okay, line L is parallel to M, so what angle relationship is happening there? So you're going to take that information, we're going to look for an angle relationship that's happening. We're going to then also use angle 1 and 2, and then basically use the transitive property and call it a day and be done. Because if you take a look at angle 1 and 2, they're congruent, right? And those are actually corresponding angles, but you're just automatically given they're congruent, so that's nice. Now, if line L is parallel to M, then what you want to do is look for either corresponding alternate interior, alternate exterior, or same side interior angles that are formed. Stephen, can you get off your phone, please? Thank you. That are formed by angles L and M. Now, if you look at line M, isn't there only really one numbered angle attached to it? Angle 3, right? Yes, no, maybe. Do we see that? Okay. So angle 3 is really the only numbered angle attached to M. Angle L has 2 numbered angles attached to it, 1 and 2. Well, which one does angle 3 maybe have a relationship with? And what kind of angle relationship would it maybe be? Corresponding, alternate interior, alternate exterior, or same side interior? It would be corresponding with angle 2. Yeah, and remember guys, if you're unsure, you can always do that like little trick with boxing in the corners, right? If you box in this corner and box in this corner, isn't that your F shape? So angles 2 and 3 are corresponding, okay? Which will mean that they're what? What can you say about your corresponding angles if your lines are parallel? They're congruent. So 1 will be congruent to 2, 2 will be congruent to 3, and then if they're both congruent to 2, can we say they're congruent to each other? Yeah, and that's actually a very common thing that happens with these. And that's basically what we're going to do. We just now need to write it down. So first reason is always what? Given. Then I give you the hint given by the picture. That means, hey, look at your picture. Angles 2 and 3 are what kind of angles? Well, Tyler told us they are corresponding. Pretty much any time I want you to look at your picture, I want you to like find an angle relationship of some sort. Okay. Now your next hint is to say something is congruent. Well, if 2 and 3 were corresponding, we can then say they are congruent. So say angle 2 is congruent to angle 3. Now, what's a good reason for that, though? Well, remember, use your vocab words, use your context clues. Didn't we have a vocab word in line 2? So we should use it then, would be my recommendation. Now the question is, what do you say? What do you write? Right? Is it definition of corresponding angles? Is it the corresponding angle theorem? Does it really matter? I mean, yeah, it kind of does. But what this is this is the corresponding angle theorem, actually. If you can't remember that, just simply say corresponding angles, or if you have parallel lines, corresponding angles are congruent, or simply say corresponding angles are congruent, or something like that. But this would technically be the corresponding angle theorem. Okay. And I wouldn't worry about that too much because it'll probably be like a drop-down box type of thing, so you wouldn't have to guess. I'm not going to put corresponding angle theorem and definition of corresponding angles in the drop-down box, okay? Okay, so now I have that angle 2, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Aren't they both congruent to the same angle? So what could I then say about angles 1 and 3? Any ideas? Doesn't do me any good to just say it all the time. They're congruent. Yeah. So say that angle 1 is congruent to angle 3. Anyone remember if you can say 1 and 2 are congruent and 2 and 3 are congruent, what property lets you then tie 1 and 3 together? Transitive. Good. Transitive. Good. So that's actually probably very similar to what the one on your quiz will look like. Maybe with one like extra step, maybe you have to tie something else extra in there. But that's the general process. Okay, questions on that one? Okay. The next one, number 2, we are given that angle 1 is congruent to 2, angle L is congruent to M. This time, prove 1 and 3 are supplementary. So you'll notice it's almost the same picture, just some different things are labeled, right? And this time, we're trying to prove angles are supplementary instead of congruent. Do we have an angle relationship, though, that is supplementary? One of our new ones? Which one, Anna? Same side interiors. And if you look at your picture, do we have some same side interior angles? Which ones? 2 and 3. Okay. So 2 and 3 are going to be same side interior angles, which means they're going to be supplementary, right? And then don't we have that 1 and 2 are congruent? So if 1 and 2 are congruent and 2 and 3 are supplementary, will 1 and 3 also be supplementary? You'll be able to like write an equation and substitute that in. And that's basically what we're going to do. And I filled in a bunch of stuff already for you. So again, this could be like how something would look on a quiz or test. So first thing is you are given, let's make sure we label our diagram appropriately. Angle 1 and 2 are congruent, and line L is parallel to line M. Again, if it gives you parallel lines, it's good for one thing only, and that's looking for angle relationships. So first thing is always your given. Angle 1 is congruent to 2, and L is parallel to M. Then I give you the hint. Angles 1 and 3 are what? Well, you always want to look for like what kind of angle they are first. So Tyler already told us angles 2 and 3 are what kind of angles? Same side interior. And that one we simply got from our picture. So we would say given by picture. Okay. Now look up at your theorems up above. They're like listed, the little bullet points. So remember, ... That would make angles 2 and 3 what? What does your theorem say? It's the word we wrote in. Supplementary. Good. Thank you, Tyler. Yes, 2 and 3 are supplementary. Now, how do we know that? Well, that was that statement up above, right, with the bullet point. Could you technically just write that statement if you weren't sure? Yes, but technically that is the same side interior angle theorem. Now, that vocab sheet that I gave you last chapter, I wouldn't get rid of that. I would probably continue to use that because I'm pretty sure the definition of supplementary angles is on it. And remember your pattern. We have same side interior angles, so we use them. Now we have supplementary angles. So should we use that vocab word? Probably. I would recommend it. What does it mean to be supplementary? That the angles add up to be 180. So if angles 2 and 3 are supplementary, I can say that the measure of angle 2 plus the measure of angle 3 equals 180. Well, I was given a vocab word, right? And we don't have a supplementary angle theorem necessarily. That's just the definition of them. If they're supplementary, then they add to be 180 is the definition of supplementary angles. Okay. Well, now we're out of vocab, but I give you a hint. And that's to say that two angles are equal to each other. Well, I'm not trying to do that 2 and 3 are equal. They add up to be 180. But what do you think I could maybe say is equal? Any ideas based on what's in the given? Yeah, exactly. If angle 1 and 2 are congruent, won't they be equal? Yeah. Now what's the point of that? Well, if I have an equation, do equal signs and congruent symbols really like go together in the same step? I mean, equal signs and congruent symbols are related, but they're not, you have to like interchange between the two of them in different steps. So if I have an equation and I want to plug something in, I need to change it into an equal sign, because here I had that 1 and 3 add up to be 180. I'm sorry, the 2 and 3 add up to be 180, but don't I want it to be 1 and 3 adding up to be 180? So if I want to be able to plug this 1 in, I need to have an equal sign instead of a congruent symbol. And that's actually what we'll do next. Does anyone remember what lets you switch between things being equal and congruent? What do we call it? It's the definition of something. Kylie? Yeah, definition of congruency or definition of congruence, however you want to say it. Definition of congruence. And I'll highlight that so we can see it. So we took this and we changed it into equal. And again, that's something that you guys will see a lot. All right. So now, again, we had 1 and 3 add to be 180, but we're trying to prove that 1 and 3 are I'm sorry, I keep saying the wrong thing. We have the 2 and 3 add to be 180, but we want to show 1 and 3 are supplementary. So, is there something that I should maybe do with angle 2? Do I want it to be an angle 2? What do I want it to be? Any ideas? I want it to be an angle 1. Am I allowed to change those with each other? Yeah, because they're equal, right? If things are equal, can I replace one with the other? Yeah, if I'm trying to prove 1 and 3 need to be supplementary, then I want to replace that. I'm going to turn that angle 2 into a measure of angle 1, right? I'm basically plugging that in there, plus the measure of angle 3. What property lets me take a value and plug it in an equation? Transitive is if they equal the same thing, so they equal each other. This is like you have a pre-written like equation with addition or subtraction or whatever. Andrew? Yeah, that's substitution. Good. Does that make sense, Tyler? Since it's like a full equation with like adding or subtracting or whatever, if you're plugging one thing in, like in place of that addition or subtraction, you use substitute. That's confused a lot. I get that. And then we're actually done because we have that they add to be 180. So doesn't that mean they're supplementary? Yeah. So that's the definition of supplementary angles. Good. Questions about that one? That's also a very common thing that you'll see, but the one on your quiz will probably be more like 1. Or more like 3, because 3 is also very similar to 1. So let's look at that one, and then I think we'll take a little break, and then we'll do the 2 on the back. Sound good? Okay. All right, so number 3, this shape, you are going to see this a lot. It is going to haunt you. in this class. I call it like the bow tie shape. It looks like a little lopsided bow tie. Happens a lot. It doesn't just happen in this chapter. It happens in future chapters too. What makes this shape special is that once you start to like see it happen again and again, there's going to be certain kinds of angles that always happen in this shape. First kind of angle that's always going to happen in this shape no matter what, if you take a look in the middle, don't we have a little X? That means we're going to have vertical angles in the middle. Okay. Something else that might happen is alternate interior angles. If you kind of visualize taking this shape and flipping it over, wouldn't you potentially have have like a Z shape going this way or a Z shape going that way? Those are things that could also potentially happen. Those are the two main things. Vertical angles are for sure going to happen, and then alternate interior angles could happen depending on like if your lines are parallel. So in this picture, we're given that angle 3 is congruent to angle 2, and that angle 5 is congruent to angle 6. We want to prove that segment PQ, that's this segment here, is parallel to RS. Now, if you take a look up above, it said use the converse theorems if you're trying to prove that lines are parallel. Well, look at your prove. Are we trying to prove lines are parallel? Yeah, so we need to think about our converse theorems. If you need to, you can always flip back to that chart, right, in your previous notes. But we want to prove these lines are parallel. That means we either need congruent corresponding angles, congruent same side interior angles, congruent alternate interior angles, or supplementary same side interior angles. Now, I kind of gave you a hint of which ones you should look for. This shape could potentially have your Z, which is alternate interiors, right? So with this one, we are going to try to figure out a pair of alternate interior angles that we could say are congruent. Because if they're congruent, the lines will be parallel. Scared me. Okay. So if you take a look here, when I highlighted it, couldn't angle 3 and 6 maybe be alternate interior angles? 3 and 6. Get your zigzag shape if you need to. Right here. 3 to 6. Does that have your Z? So are those alternate interiors? Yes. As of right now, they're not congruent, but we can show that they are. Because isn't 3 congruent to 2? And isn't 5 congruent to 6? And do you guys remember what kind of angles I said we're going to have in the middle? Vertical. And vertical angles are always what? Congruent. Yeah, they're always congruent. So won't 2 and 5 be congruent as well? So if 3 is congruent to 2, 2 is congruent to 5, and 5 is congruent to 6, aren't all these going to kind of be congruent? Yeah, and that's basically what we're going to do and then use the transitive property. So let's put our given. Angle 3 is congruent to 2, and 5 is congruent to 6. Angles 2 and 5 are, we just talked about it. Andrew just told us they are vertical angles. So angles 2 and 5 are vertical angles. That is given by the picture. That's one that you want to look for a lot. Okay. And if they're vertical angles, we can always say that vertical angles are what? Congruent. So we're going to say angle 2 is congruent to angle 5. So now we're actually, it's easy to look at this and be like, oh, we're actually like done. Because if you look at your given, we now have that 2 and 5 are congruent, right? So won't 3 and 6 be congruent? Definitely, but they can't just be any old congruent angle. They have to be an angle relationship. So we have to make sure we say that too, right? Because like not every kind of congruent angle is going to make parallel lines. It depends. So we want to make sure we state that angles 3 and 6 are alternate interior angles. Oh, I forgot my reason here. I almost missed it. If angles are vertical, then they're congruent. Anyone remember what that theorem is? I'll use your context clues. It's the vertical angle theorem. We had vertical angles, right? So that is the vertical angle theorem. Good. Okay. Then 3 and 6 are alternate interior angles. That's also still given by the picture. And on your quiz, if there's going to be steps that are given by the picture, I'll have that reason filled in for you already. You'll just need to maybe identify it. Okay. Now we have something is congruent to something else. Well, what was the whole objective? Which two angles were we trying to show were congruent? 3 and 6. So angle 3 is congruent to angle 6. That's the transitive property because they were both congruent to 2 and 5, right? So they're congruent to each other. And now we have that angles 3 and 6 are congruent. They're alternate interior angles. That means my two segments are going to be parallel. Now, as far as reasons go, it's technically the converse alternate interior angle theorem, or you can write it out again. If you're ending with parallel lines, you have to use the converse theorems. So we're going to say converse alternate interior angles. We won't worry about writing like theorem necessarily. And again, on your or on your quiz, it'd be like one of the multiple choice selections in your drop-down box. Oh, that's why that's acting weird. It turned off. Okay, so converse alternate interior angle theorem. All right, questions about that? Tyler? Angles 2 and 5 for number 3. They'd be vertical angles. Oh, I see, because you're seeing like the V shape. They're never, alternate exterior angles are never connected like that. Does that kind of make sense? They're always going to have, like one's going to be on one end of your diagram, the other's going to be on the other. Okay, does that make sense? Okay. Anything else? All right, number 4. Here we are given, this is the same picture as the one before, I don't know if you noticed, but in this situation, we are given that segment PQ is parallel to segment RS and that angle 4 is congruent to angle 5. We want to prove that angle 1 is congruent to angle 2. This is very similar to what we just did. We're going to use a lot of the same strategies here. Because if we have two parallel lines here, remember your bow tie shape, you're going to have alternate interior angles. So if these lines are parallel, you're going to have congruent alternate interior angles. Now, you could have them going either way. You could do your Z shape this way if you wanted, but do angle 3 and angle 6 have anything to do with my proof? No, I'm not told anything about them. I'm not trying to prove anything about 3 and 6. They don't really help me. But what if I maybe went the other way? What if I looked at my alternate interior angles this way with 1 and 4 in the corner. Could that maybe be helpful? Yeah, because aren't we trying to prove something about angle 1? Are we given information about 4? So that's probably the more reasonable way to look at that one. So we have parallel lines. That means we're going to have our congruent alternate interior angles. So we're going to be able to say 1 and 4 are congruent. We also have 4 and 5 are congruent. Well, think about what we did last time. How in the world am I going to like bring angle 2 into this? Think about what angle relationship always happens when you have your bow tie. Anyone remember? Vertical. So angles 2 and 5 will be vertical again, right? Which means they'll be congruent, which means 4 will be congruent to 5, 5 will be congruent to 2. And aren't 1 and 4 going to be congruent? Yeah, so all this like whole line right here is going to be congruent. We can tie all those together. All right, so first put your given. Segment PQ is parallel to segment RS. That is given. And now we're going to say it's giving us a hint. Angles 1 and 4 are what? Well, anytime you're given a hint like this, it's saying, look at your picture. What angle relationship is happening? So I've already said it a couple times. Angles 1 and 4 are going to be what angle relationship? Andrew? Yep, these are going to be alternate interior angles. And that is given by the picture. Good. And if we have parallel lines, then what can we say about our alternate interior angles? Well, it gives you a hint here. It's saying, hey, say two things are congruent. So if you just said 1 and 4 alternate interior angles, which two things do you think it wants you to say is congruent? Angle 1 and 4. So angle 1 is congruent to angle 4. And we were given alternate interior angles. So we are going to use that theorem. We would say the alternate, I always switch my pens too quickly and then I end up writing in the wrong thing. So this is alternate interior angle theorem. Good. Now it's saying 2 and 5 are blank. That's again, we don't really know anything about 2 and 5. It wants you to look at your picture. What angle relationship is happening with 2 and 5? We said this same one in the last proof. Tyler? Vertical angles. Angles 2 and 5 are vertical angles given by the picture. Good. So then you'll see again below, it wants you to say two things are congruent. Well, what do we know about vertical angles? They are congruent. So angle 2 is congruent to angle 5 by the, again, you're given a vocab word, use it. You have vertical angles, use the vertical angle theorem. Good. Now it wants you to finish. It wants you to say 1 and 2 are congruent. How could you possibly do that? Where do we have information, Trey? Yeah, we could technically transitive property, but yeah, you could think of it as substitution. We know that angles 1 and 2 are congruent to 4 and 5, right? And in your given, weren't you told 4 and 5 were congruent? So if 4 and 5 are congruent, then 1 and 2 are congruent. That would technically be the transitive property. But that's again a situation where if you often get that confused with substitution, like in the drop-down box, I'm not going to put both transitive and substitution. Okay. All right. Last one. How are we doing so far? people who it's your first day in class, how are we doing so far? Okay, okay, all right. All right, so last one, this one is the doozy, as you can see, but I filled in a ton of it for you, so we'll get through it. This is actually a perfect example of I can give you like this crazy long proof, and if you use your context clues and fill in your blanks, it's doable, okay? So we are given that line or segment WX is parallel to YZ, so that is these two top, or the top, no, the left and the right, sorry. I give you that these are parallel. Oh no, I was reading the wrong one. I was reading the proof. We're trying to prove those are parallel. I give you that the top and the bottom are parallel. Okay. And I give you that angle 2 is congruent to angle 3. We're trying to prove that the left and right are parallel. Now, if you are trying to prove that lines are parallel, that means find a congruent or supplementary angle relationship. Now look at all your angles in this. Think again, think like acute or obtuse. Is angle 1, here I'll zoom in a bit. Is angle 1 an acute or an obtuse angle? Obtuse. What about angle 2? Acute. So are those going to be congruent or supplementary, most likely? Supplementary. And then same idea with 3 and 4, right? And same idea with 1 and 3 and 2 and 4. When you have a picture like this, these are all actually same side interior angles. So we're going to show, we just need to show that a pair of them adds up to be 180. That would make segment WY be parallel to XZ. So we either need to show that 1 and 3 add up to be 180, or no, I'm sorry, 3 and 4 add up to be 180, or 1 and 2. I think I take you on the route of 1 and 2. Hence why I filled in a lot of it. Okay, so let's just follow our context clues here. Given is already filled in for you. I split up the given in this one because it's such a long proof. So our first given that we're going to use is that segment WX is parallel to YZ. That is given. Then I'm telling you angles 1 and 3 are what? And I'm saying, look at the picture. So angles 1 and 3, what kind of relationship can you say that that is? Same side interior. Good. So we're going to say angles 1 and 3 are same side interior angles. You can also abbreviate that as SSI if you want. That's what it does over here. Okay. Angles 1 and 3 are blank, and I'm giving you the hint. If lines are parallel, then same side interior angles are what? This is the only one that would be, you can look at the front if you're not sure. Supplementary, yeah, that's okay. Yeah, angles 1 and 3 are supplementary. So if lines are parallel, then same side interior angles are supplementary. That's technically our supplementary angle, or no, I'm sorry, our same side interior angle theorem. Good. So now keep going with your context clues. We had supplementary angles, which means we can say angle 1 plus 3 is going to add up to be what? 180. Good. And then over here, I'm giving you a hint that that's a definition. What would that be the definition of? Yeah, good. Definition of supplementary. Oh, I don't know why that's moving like that. I don't like that. Definition of supplementary angles. Okay, good. Now I put in the other given for you. It doesn't matter if they're in 1 or 2 lines. And then I'm giving you another hint. The measure of angle blank equals the measure of angle blank by the definition of blank. Well, isn't there only one place that we've said anything about 2 angles being congruent or equal or anything like that? In the line above, we said 2 and 3 are congruent, right? If they're congruent, can we say they're equal? Yeah, that's allowed. So again, context clues. Angle 2 The measure of angle 2 equals the measure of angle 3. What definition lets us switch between those? Good, definition of congruence. Ew, I wonder why it's moving like that. That looks weird. You guys notice that when I write it? I don't like that at all. Okay, so then we have that the measure of angle 1 plus the measure of angle blank equals 180, and I'm telling you to substitute. Well, if you take a look up in line 3 or 4, I can't see right now, line 4. Don't we have that the measure of angle 1 plus the measure of angle 3 equals 180? Now I'm saying that the measure of angle 1 plus the measure of angle what equals 180? Well, it was 3 before. Oh, that's okay, Natalie. So it was angle 3 before. Any ideas what they want you to substitute in there? Angle 2, because in the step above, we said 2 and 3 are equal. So I'm going to take angle 2, always does that, and plug it in there. Right here, I'm basically taking that and plugging it in, 2. That's the substitution property. All right, then, giving you a big hint, 2 and 3 are what? If they add up to be 180, what do we say that that is? Yeah, good. Angles 1 and 2 are supplementary by the definition of supplementary angles, right? And then I'm giving you another hint. Angles 1 and 2 are blank, given by the picture. Anytime it wants you to look at the picture, look for a relationship. 1 and 2, aren't these along the same side? So these are same side interior angles again. I'm abbreviating that with SSI because I just write too big. And then we're done. Segment WY is parallel to XZ because we had same side interior angles and they were supplementary. So if same side interior angles are supplementary, then we can just say, then this is like that converse. So if the angles are supplementary, then the lines, ew, I don't like that at all. Why is it, ew, why did it do that? Pretend like you can read that. Then the lines are parallel. And that's not an 11, that's a parallel.